Welcome back everyone to theCUBE's live coverage here in Las Vegas. This is Dell Tech World 2026. I'm John Furrier, host of theCUBE with Dave Vellante, my co-host. Dave, we've been following Dell Technologies for years. This is like our 16th, 17th year of theCUBE. Always great to have the tech experts come on. John Roese is back, he's an CUBE alumni, Global Chief Technology Officer, and currently the reigning Chief AI Officer at Dell Technologies. John, great to see you. What a year it's been. Last year, when we were here, what a different world it's been. AI factories, what are you going to run on it? The puzzle's being solved, the pieces are coming to the table. Thanks for coming on theCUBE, how you been?
I have been super busy. It has been a amazing last year and it's only accelerating, so.
The puzzle pieces I mentioned, I want to get your thoughts.
Yep.
You know, 2 years ago, you put the puzzle corners together.
Yep.
What's filled in? What's changed this year the most in your mind?
Yeah, I mean, it's almost impossible to answer that because almost every month we're changing something, you know, it's, but if you put it all together, okay, year over year, the difference is, first, it's now agentic, it wasn't a year ago. When we were talking about agentic, I was introducing people to the word agentic about a year ago. Now we've realized that, you know, this idea of fully autonomous AI systems, of really shifting work into the machine layer is now very real. That's good, take that for granted. At the same time, you know, not that we didn't have enough to do, the word tokenomics is now in our vernacular because we've realized that when you put these things into production at scale, the cost of different patterns of what you deploy are incredibly variable. And so having a smart, intelligent way to use your hybrid infrastructure to put the right workload in the right place, use the right model, is actually not just a nice to have, it's required, otherwise your costs are going to go out of control. And then on top of it, if we weren't busy enough, we had personal agents show up a couple of months ago, which basically we predicted, we always said agents would be distributed where the work was. We hadn't predicted necessarily OpenClaw, NeoClaw, Hermes, but they came into existence, and to us, it wasn't a surprise. It was an obvious evolution. So we're very much in the distributed, agentic, and economically sensitive AI world that we have to navigate.
You know, I talk to a lot of people all the time, they see my laptop, oh, Dell Technologies, yeah, AI factory, Dell, AI factory. So the old Dell, I'm dating myself, but servers, PC, and storage, the new Dell, AI factories, agentic infrastructure, automated orchestration, private AI clouds, we'll come back to that, rack scale systems, AI operations, cyber resilience and recovery, full stack deployment blueprints. This is a huge ambition. Okay, let's chew on that. That's a lot of new Dell. How much this year do you see really lining up? Like private AI clouds, kind of, it's not private AI, it's private, it's not private cloud per se, but it's hybrid cloud with private.
The reality of it is like most of the underlying foundational capabilities that, you know, these are all based on have existed for a while, but they needed to get recreated for the AI era. You know, a great example is the AI data platform. There's been data management platforms for a long time, and in fact, if you look at it like face value and say, what features does it have? You know, it's just another data platform. Yeah, we think it's very good. What makes it interesting is no one's ever really taken a data management system and plumbed it into the accelerated interfaces of an AI factory to make it run an order of magnitude faster. That's the magic. It wasn't that you can run a data management workload on it. This is not data separate from the AI compute. This is data as an integral component of an AI factory. And that's nuanced, but what do you need to do that? Well, you can't do that as just a software company. You have to understand the hardware, you have to understand the compute, you have to understand the networking, you have to understand agentic, and so, you know, our strategic advantage, interestingly enough, to that big long list is actually the advantage. That you can't do AI with just one of them. You have to start to look at everything. Now some of the new areas, like what does your dynamic IT infrastructure look like, a private AI hybrid cloud, there's ways to do that in more modern approaches. You can use template-based configuration, agentic configuration, AI data or AI automation layers. All of those are figuring out how to do something that's been around for a long time, an IaaS, a platform, but do it for the AI era. That's the opportunity.
I have to ask you, because this comes up a lot on theCUBE, certainly in Palo Alto, Boston, and NYSE. A lot of the legacy enterprise stuff is brittle. We don't need to talk about that, but it's not going away either. But a lot of those systems weren't built for what AI demands. You mentioned plumbing data platforms into AI factories as one example. What is the biggest challenge the enterprise have to make all that work? Because if you got a CRM or an ERP and HCM, it wasn't built for the kind of real-time data pipelining that, it's a query engine basically, get a report. Yeah. Now it's a system of record to the system of intelligence. What's the big challenge for the enterprise to make all that work?
Well, the big challenge isn't those things. You can make those things work in the context of an AI environment by putting an MCP interface in front of it, letting agents control it. You can take, let's call it dumb infrastructure and make it smart by putting AI adjacent to it, and that's fine. But you can't do that if you don't have an AI factory, if you don't have an AI environment. So the biggest impediment to kind of navigating the legacy environment into the AI era is this mistake of thinking you're doing it by having the legacy environment be the anchor. The only way it works is you have to actually have an AI environment, you have to have a place to build agents and run them autonomously, you have to have a security architecture that works with things like agentic. But once you have that anchor, you're not replacing every legacy system, they simply become tools and APIs and interfaces that your agentic systems can take advantage of. And eventually maybe they will go away, but it's unnecessary. The brownfield becomes a feeder system to the new AI environment, but if you don't have the AI environment at all, you're just kind of putting some AI features around a brownfield. And
you're bolting it on.
You're bolting on AI. Built in versus bolted on. Built in's a better choice, and you got to do that as a new anchor. The center of the universe is not your legacy environment, it's something new, but it's not mutually exclusive.
But there's value there, to your point.
That's where your data is. I love the systems of record. I extract their information, I vectorize it, and I use it in chatbots. I extract it and use it in knowledge graphs. But they coexist, but which one is the dominant party? It's the AI side, not the legacy. And that's a big shift for people to stop thinking that the center of the universe is the system of record. That's just a data source for the new center of the universe, which is the agentic environment.
So I want to come back to that because it seems then the logical path would be that the AI factory infrastructure absorbs a lot of the functionality that was typically going through the CPU I/O path, storage, security, and other management capabilities. Now it doesn't happen overnight, but do you buy that premise that a lot of that functionality gets absorbed into the AI factory over time?
It turns out that once you have an AI system, what you realize is you're not building a classical IT stack where there are explicit systems of record and explicit applications. You're building an environment that's incredibly dynamic. And let me give you an example. The difference between a coding assistant and an autonomous agent is zero. They're the same thing. Every agent in the world can write code, and every autonomous coding assistant is just an agent. And so when you think about those two worlds converging, look out maybe, a year into the future. If an agent needs to calcify functionality into software, it will just build its own tool. It will create software. So today we kind of think of there's the legacy software world and the software world, and then we put agents in the middle and they use them as tools with MCP. No, the reality is long term, the agents are going to get a decision. Do you want to use that legacy tool or do you want to build your own tool? And they're perfectly capable of doing that, which means today, when you start, it is essential that you link you make accessible your systems of record and your existing tools to the agentic environment. But it's also critical that you realize that that is a moment in time. And as the agents evolve, they have the ability to make that legacy software different or better or agentic friendly, and sometimes the way that will happen is they will simply render that software unnecessary and replace it with more modern tools and more modern software. That's a very disruptive principle, but it is exactly what's going to happen.
So those deterministic systems come together with the probabilistic systems, but I have a note here that AI value comes from process transformation, not tools. That's from you.
Yes.
And so I want to poke at that a little bit because I think it's profound but not necessarily well understood. I think a lot of people think, okay, I always call it paving the cow path. Hey, we can do this existing process better. That's not what it's about.
Yeah, and you can get, when we said that, what we meant is the end state that you're trying to deliver is is work, and work is enumerated as processes, and in the AI world, you have the option of doing that work in a different way, distributing it to different functions, doing it faster, doing it more autonomously. So if you don't anchor your AI strategy and what you're trying to do around actually creating new processes, new ways of working, you're just kind of improving whatever you have today, which is okay, but not really transformational. And so I think that that's played out. It played out with the way we implement chatbots. It's definitely how we're playing off with agentic. And as we go forward, I think we actually are having an internal discussion about this, that we're developing the training and certification of our internal team members as we move into our next phase of AI around agentic, that we're really going big on agentic. And it was funny because we are doing general purpose training for everybody. We've been doing that for a long time. We are doing like 301, 401 deep training on how to use our agentic platforms, how to build agents, and that's for a very broad audience of practitioners. And then we had this discussion, we said, the other training we need is we need to retrain all of the people in the company that focus on process engineering to actually know how to do it in the AI era. It's as important as training the engineers in our world, and they're not like one's better than the other. We actually have to do both, and it was a kind of an aha moment that if we don't invest as much time and energy on helping people understand that the way you develop and deliver process, the way you do work, actually has to be thought about differently, you will actually not define the objectives of the AI project to actually be aspirational enough.
What is the mindset on that? Because this comes up a lot. This comes up under culture, it comes up into innovation, it comes up into reskilling and upskilling.
Yep.
What is the mindset when you do that training? What's the premise, and is there like a playbook, outcome-based?
Yeah. Absolutely. In fact, some of the things, Dave used the term, one of the first topics that we cover, actually in both tracks, is how to understand probabilistic systems. Now it sounds very technical, but it turns out that if you don't understand how these things actually work, you're going to make a terrible mistake, both in process engineering execution. I'll give you a funny story. We have a project going on. We're building an expert level multi-agent system to do quoting, and it's going to be a long process. It's going to take a while to get this one right because it's very complex. And in the early days, one of the things that you do in the quoting tech refresh process is you do configurations. And so we tried two experiments. One path, a team went off and said, what if we take all the configuration data and give it to a large language model and try to do it within the LLM, in the probabilistic side? And you can imagine that did not go well, because every time you asked it for a configuration, it gave you a different configuration, because that's how they work. And then another team, who I think was a little better at this, said, wait a minute, it is essential that the configuration be deterministic. So what they did is they reskinned our configuration tool, which is a very good tool, to make it agentic friendly, and the agent did the minimum sufficient reasoning, and when it got to the point that it needed a configuration, it just made an MCP call to the configurator.
Give me a configuration.
It turns out it was economically cheaper because a whole bunch of work was being done on CPUs. It was way more predictable, the agent was simpler, and the outcome was better. And it's like, wait a minute, less reasoning, less agentic is actually a better outcome than a bigger agent with more stuff in the LLM, and that's part of that curriculum, to educate people. More is not always better. Minimum sufficient reasoning is what is really the sweet spot.
Dave, you actually brought this up in our first interview kicking off Dell Tech World, which is, they're not about either or, it's not about non-deterministic versus deterministic, because you can use the non-deterministic to get your determinism. Meaning, we as humans can relate to this by saying, feed the AI, and don't rely on it. Use the rules or known data and convert non-deterministic to deterministic.
Well,
that's what you just...
Well, to me this is fascinating because it has organizational implications, because in some ways determinism is sort of a myth in that my historical system of analytics has determinism.
Exactly.
My other SaaS systems have determinism within their own stovepipes, and my organizations have their own departmental versions of the truth. That's dissolving away. That's the new operating model, and that's profound.
I love it when people think that like the way we work today is entirely deterministic. There's a piece of our existing process that isn't. It's called humans.
We think non-deterministically.
We have opinions and biases and things that are not predictable.
We adjudicate.
Exactly.
We make exceptions.
So to expect an agentic system to be anything other than that, but how do we mitigate it? Well, if we create ground truth, we create tools that are predictable and we surround ourselves with them, and the result of that combination of judgment and reasoning and predictable analytics and processing actually gives us the necessary tools to kind of achieve that sweet spot. it should not come as a surprise that agents will use tools and software and reasoning are both necessary. These are just obvious in hindsight. Like everything in AI, the first time we do it, we don't know what we're dealing with and we have to go through a few iterations, but we're now past that.
So how far does Dell go? You got the infrastructure nailed, you're innovating there, you've got the integrated data platform now. You're not, I mean, you got to deal with Palantir, that's kind of cool. I don't think your swim lane is the, Palantir-like ontology for all, right? But you could be the harness, the guardrails around that, the scaffolding.
Yeah.
Where do you go?
Well, our anchor is the actual infrastructure, the performance layer, the data, and that will always be our anchor. That's what we are, very proudly an infrastructure company. But like I said before, like the AI data platform isn't an orthogonal relationship to our infrastructure.
Right.
If we built it as just a standalone product, it was just software, and we tried to compete in the software world independently, we'd probably do okay, but it would confuse you as to why we're doing that.
It'd be like an MPP database.
Yeah, exactly, I'm not sure I need that. But on the other hand, even though I'm doing that, if I link it deeply to the acceleration interfaces, to the GPU environment, it is not orthogonal to the AI factory. It's part of it, that's in scope. So for us, things that make the AI factory more complete as infrastructure, which does include things like the data layers as necessary if they're accelerated. It definitely includes networking, it includes a bunch of other parts. Those are things that we with our ecosystem will deliver. We don't do vertical applications, we don't compete with our customers. Those are things we've never done and probably won't do, because honestly, we're way better at enabling everybody than trying to go pick a fight to be like a healthcare company or a transportation
You're an
company.
enabler.
We're an enabler.
And that leaves a lot of meat on the bone for the ecosystem, right?
Absolutely,
I mean,
and we like that. We like a healthy ecosystem around us. We like to be clear about what we do and what other people don't, but we are unapologetically a broad line infrastructure provider, and AI is a bigger infrastructure than we've ever had.
And AI infrastructure is on the center stage.
Yep.
It's the #1 conversation. Energy and money are bounding the function. And also the hyperscaler only model is not breaking, but it's not the only game in town. It's certainly doing well.
Well, it's hybrid. You guys have known me for a long time. I mean, I have for 15 years said hybrid is the answer.
We can witness that. We witnessed that.
You've witnessed it. I'm on the record. Michael's on the record. We have never strayed from this idea that you need a distributed hybrid infrastructure so you have choice.
End to end.
You need to make it work as a system. You can't just have fragmented pieces all over the place. But when you have the ability to decide this AI system is going to run on a PC or on a GB10, it's going to run at the edge, it's going to run on a co-location, it's going to be a modular data center, it's going to be in your data center, it's going to be in a VPC, it's going to be in a cloud. When you have all those options and the ability to coordinate them, you have a very powerful tool, not just to deploy AI, but to optimize it and make it efficient. And any company that positions the right answer as you get one choice of where to run AI, I just can't fathom why anybody would listen to them, because the complexity of these systems is quite high and the distributed nature of them requires us to have that kind of architecture.
Well, look, you guys were right. We can witness that and give you props and say that's the fact. Also, Dell's done the work. That's why the business performance is up. So, hats off to Dell. You did the work, you saw the vision. My question for you, and I'd love to get your thoughts on this because it's the hottest area, and we just had the agent conference in New York last month. There's a level of agent engineering going on. We've talked about this last year, but I want to get your thoughts now. It's not DevOps, cloud native folks, but it's kind of like an overlap. And they're not AI native developers slinging models and doing OpenClaw and those things. It's a kind of an engineering role, some people call it agentic engineering layer, that's going to sister up against cloud native. What do you call that? What is actually happening? Because this is the MCP stuff. This is the data plumbing.
I have a whole organization, and we've distributed that organization out into the business units called AI-centric engineering. That's the term we use internally. And it's, funny enough, almost everybody in my, what's called ACE team, which is AI-centric engineering, have a background in cloud-native development. They were all in our pivotal style dojos. Many of them ran those dojos, built those dojos. We pivoted that entire team to be the anchor of our AI-centric engineering, and it turns out there's a lot of similarities. Some of the similarities are around architecture, that you have to be very thoughtful of how you build this, so having proper TPMs. We did, in a dojo, we had pretty much paired programmers and TPMs. In an AI pod, which is the new unit, you add two components to it. You have data science, and you have AI engineering capability, which are people who understand the AI stack and tools. So our atomic unit of work is a team of a TPM, paired programmers, data scientists, and an AI engineer or two that understand the new tool chain. You put those together, they become the atomic unit that executes. That's that layer.
By the way, I 100% agree with you. I was just having a conversation about that cloud native, it's all one thing. Next question to follow up on that is...
Wait, whose responsibility is it to govern that? Is it the AI engineer, or is...
Well, to govern the process is the TPM.
The TPM.
Well, I love technical product managers. That's the cloud native, if you know how it works. When you do extreme agile or paired programming, the developer is not the one running the show, it's the TPM. The TPM does the user stories, the TPM manages the backlog. That model works exceptionally well.
Make sure it's compliant,
yep,
okay.
Exactly.
Awesome, this is great, good data. I'm getting a good pound of flesh here.
Masterclass.
Okay, got the cloud native, I see that 100%. They're not different personas, all blend, engineering the same thing. What do you see happen coming from the other side of the tracks? From the application side, we're starting to see people that know containers, they know what Kubernetes does, but they're not necessarily in the weeds on cloud native. Is there another set of folks coming into that genre? On the app side, that's not just coding away.
No, they're coming in, but they're coming in a little differently. Either they're completely reinventing themselves to be part of these AI pods, or they're playing a very different role. Those people, when you think about how you build cloud native code, if you've ever, if you build a new, like on Cloud Foundry or Kubernetes, and you build a new composite application of microservices, a bunch of the work isn't technical. It's about thinking about the functionality you need to achieve the kind of business objective, to make the thing work. And it turns out one of the most important things in an AI project isn't the actual technical effort, especially with agentic. You don't actually code a lot. It's mostly configuration and data management plumbing, but you can't do that if you don't know what problem you're trying to solve and what the architecture is. And so, in many cases, those people don't write any software, but what they do is they come in with a thought process that was very present in cloud native about decomposing the problem into a set of problems that can be solved. With AI, those translate to a set of agents that do specific work that end up working together. And so I actually find more of the people in the business unit not actually prosecuting the low-level AI work, but because they're technically proficient and they understand the business context, they can have a very intelligent discussion about what process we're trying to recreate. How do we break it up into components that are agents that will achieve that outcome? And so, I'm biased, but on either end of the spectrum, technical people are useful.
So I'll throw something at you. I'll throw something at you can react to. So one of the things I'm seeing is the database role. Because you can have a graph database for a certain use case. That's architecturally in the realm, but it's not necessarily microservices. So they're database folks. Data platforms are emerging. We're hearing harmonization layers, the semantic layers, control plane. Is the role of the data team, data engineering, database?
Hugely important. The biggest work item on every advanced agent we've built to date has been the data plumbing. And it's not like we have a data mesh, we have a lot of things that allow this to be very easy, but it's understanding the data flows and what data should exist and whether or not it's in the proper state. And so I actually, remember in that AI pod, paired programmers, TPMs, data scientists, AI engineers. There's a reason for those four. The data science work is no longer theoretical algorithm development, it's actually doing the hard work of actually figuring out, in order to make this agent do this thing, it must have access to data. Now sometimes the data is just transactional. The biggest thing that they spend their time on is converting institutional knowledge into knowledge graphs and ontologies that the AI agents can use. That is strategically valuable. And an agent that just has access to a large language model is not an enterprise agent. An enterprise agent also has access to a knowledge graph that organizes the proprietary enterprise knowledge. If you give an agent both of those, and the knowledge graph is ground truth, it behaves better, it is more relevant, it is more aligned to your business.
So that changes the operating model. We have to have John back, literally, for like a 2.5 hour.
I have one more question. I know we're going a little over, but I want to ask you. data gravity used to be the problem. You heard that, still kind of talks about, but data pipelines.
It's pipelines.
Coding, static code, agents don't know what the syntax was that you might have statically coded. What's your reaction to data pipelines?
No, we think data becomes very dynamic and pipeline. Now we'd like it to be through orderly interfaces. We like publish, subscribe interfaces, we like data meshes, but we acquired Data Loop and added it to the data. What did it do? It does annotation in the data pipeline. It cleans data up.
And there's a knowledge graph inside of
exactly,
that too.
and the accessing data to an agent is the flow of data across the enterprise, not data stagnating in a pond or a lake. This is a very dynamic data system and you expect it. Now it's different data, it's knowledge graphs, it's vector databases, it's things that are different, but I cannot underemphasize how dynamic an agentic system is, both in terms of it and the data around it.
And it includes process knowledge.
Absolutely.
And the underlying application logic.
Well, I'll give you a last thing. One thing we are doing is we are big believers in digitized process. We use certain tools to basically take our processes, digitize them. In the old world, that digitized process led humans around. In the new world, when we build agents, one of the tools they use to accomplish work is they go to our digitized processes and ask how they should do the work. It's sitting there, it tells them what the happy path is, it tells them how to solve a problem. The value of giving agents more information about what the process is, how they should work, rather than letting them invent it, just makes them more predictable and more scalable.
John Roese, thanks for coming on. We got John Siegel waiting on deck here, got the whole lineup. Thanks for helping us kick off a great event. Great to see you, congratulations. A lot more work to do, but so far so good, looking good. Middle of the fairway, as we say in golf. Thanks for coming on. I'm John Furrier, Dave Vellante. We'll be right back after this short break.
Okay.